So here's a test with a new bulb. That's this is like one of the Tesla brush style bulbs where it's got a an outer bulb and an inner bulb, and the inner bulb has a tube going all the way down the neck, and down towards the bottom is a coating in copper, which makes it easier to hook the neutral up to, rather than wrapping a piece of foil around it. And the inner tube with that small bulb you see in the middle, that actually has gas in it, but it's not illuminating. We might not have enough power to get that far into the bulb. But what's interesting is that this outer bulb that is illuminated, it has no gas.
It has no gas. That's a hard vacuum. That's 6.6 times 10 to the minus 7 microns.
Yet it glows.
Yeah, that's baffling.
And again, what kind of vacuum is on it?
It's a really hard vacuum. It's 6.6 times 10 to the minus 7 microns. So it's a really extremely high vacuum. You call it ultra high vacuum. See, that's how that inner should glow. It should glow like that. And I don't know why it's not. Ding. And this one, yeah, see, this one has gas in it.
So that one has gas.
That has gas in the outer bulb.
But the other one glows yellow.
And this one does not. And it won't, it shouldn't glow at all until it's hooked up.
And when that one glows, it's yellow and there's no gas?
Right, and this was the one that gave us that flame that wrapped around on the inside. It was very strange.
And then it started going, bigger and bigger?
Yeah.
So it's interesting how that one has no gas and it's yellow, and this one has no gas and it's purplish.
Yeah, I'm not sure what's going on here yet. I know I want to take this bulb home with me, open it up, and pull a hard vacuum on the outer bulb.
Is that the one with no gas?
This is the one with gas in the outer bulb. And I want to open this up, pull a hard vacuum on it, and then we'll see if it acts the same as that one.
Okay.
And it should. And I'll go ahead and coat this also with copper, so we'll have a good solid connection.
Should we try one of the other bulbs you brought?
Sure.
Okay.
We need.
Okay, so here's the next bulb we're going to test, and how does the vacuum compare to the last one?
Outer jacket, same, hard vacuum. They were all pumped at the same time. The internal gas is 10.1 millimeters of mercury backfill. And this is a nitrogen-hydrogen mix. So we're 94% nitrogen, 6% hydrogen.
Okay, and that inner bulb is physically bigger than the
first test. Yeah.
Last one. Okay. Okay, so this also has the same vacuum in the outer tube and get completely different colors. Well,
what is that? That's weird.
makes it hard to tune because it's...
Well, you get a faint glow in there and then it does that.
Yeah.
That's odd. But then this whole thing is odd.
Well, you remember one of the inner ones would light up and it'd blink out, and then they're like a photo flash capacitor.
Yeah, yeah.
Discharging almost. So let's see. We're pretty much.
You can see the glow build up and then it. And you know, Tesla said that sometimes it would take up to 2 weeks
Condition them.
for his
That's right.
for his bulb to start rotating.
Weird.
Yeah, it is. I wonder if it's because of the aluminum, just not a real tight coupling. Oh, that was almost. Whoa, there we go.
Well,
Now we're getting our center. The Eye of Sauron. Look at that. Now that's different.
oh, and look at it.
Yeah.
It's got rotating beads going this way,
Yep, yep,
90
yep.
degrees to the.
So that's a little bit higher internal pressure on the small bulb.
Okay.
That's 10.1 millimeters.
Let me see if I can
Look
get
at
a
that.
picture of those little
man.
rotating. Oh shoot! And then that outer one is now yellow, and then it was blue before. Remember?
Yeah.
Okay, so let's see if we can. But you saw the little circulating bead things that were going around
Yeah,
like
yeah.
that. Okay, let me see if I can.
Now see, this is located. There we go. Can you get a close up of that?
Trying to.
Because that's two halos. Wow. And see, this is on this side. That yellowish green. It's on this side. It's not all the way around it. It's
Yeah.
located in one position.
So,
There.
okay, so
Wow.
so those beads are going.
Now there's our flame is
Oh,
kind of oscillating around the stem.
interesting. Okay. Or should put some music to it. Okay, so that's flickering on its own. Okay, so if we pull it out. I wonder how come it's not blue in there anymore.
I don't know. That's the whole thing is just
The whole thing's like an optical illusion, you know, that almost looks like a flat. You know, I'm seeing a blue ring.
yeah. I see
Around
that.
it.
I see that too. It's almost a reflection of ionized, but it seems to be corresponding with that yellow flame. And what's weird is the flame, like you say, it's concentrated on one side. It's not.
I'm detuning it. Yeah.
See, and as you detune it, it kind of spreads out through the whole bulb. But as you tune it in tight,
And how come it's not blue anymore? You know? Like this other tube, you know, it's yellow inside like that. Okay, it's doing that on its own. Destabilized. See, it's like when it's tuned, it's like the ether is stretched really tight, and it keeps it stable. And when you detune it and you loosen it a little bit, then it can kind of
Spread out.
it's like it wants to do its own thing. So that's pretty much peaked at full power that we can give this thing.
Yeah, I didn't even have to touch that to get it to light. That doesn't seem to make any difference.
You lit it off the neutral.
Yeah. And it's showing strong field strength on the sides.
Put it on the outside. It's not supposed to light up on the back side.
It's still lit. Still lit. Our flame is more green now than it was.
Mm-hmm.
Now, are we going to get back to that center bulb action again? Or is it just going to do this and get brighter?
We remember in the small tube how it just kind of kept growing in size.
Yeah.
It was,
Well, but when it started off, it had a black center in it. Remember, it was kind of like an eyeball. And then it just, then it went to a flame, a yellow flame.
mm-hmm.
Look at that. Almost looks like
That on. What shape is that?
Yeah, that's just full,
But it's still like it's not touching the sides on the left and right.
right. I want to see that center light up again and do its thing. And I'm still wondering how we're getting any type of a glow at all inside of that hard vacuum like that. There's something there that,
Yeah, in different colors. The other one is purplish.
oh,
This started off blue. Now it's yellow.
and that's not the same type of yellow that you would get as a sodium flare from the glass. And I guess the best way to test that theory would be to bring a set of didymiums down and see if that color goes away through the didymium.
What is that?
That's what we use as glass blowers. That's what we use to see the glass. With borosilicates and soft glass, when you hit the flame to the glass, you get what they call a sodium flare, which is a real bright flare off the glass, and then you can't see the glass. So we use didymium filters in our glasses that filters out that sodium flare, and then you can see the glass itself and work it. That's definitely going with the music.
So that's one of the Bach pieces. And you know what? On the inner bulb, there's like a pinkish
I see it. Yep.
all the way around, like it's just on the I can see it from the bottom up too. It's, see that?
Yep. Now look, our flame is starting to envelop that bulb. That's kind of a fan. If you look at it from this direction,
looks like a disc.
Yeah. Like a crust.
It's like a pure ether glow. I mean, like what else is in there other than
There's nothing in there. That's a
Space.
hard vacuum, man.
just space itself?
Yeah.
The illumination of
Is
space.
this what they call the energy from the vacuum?
It's like a pure ethereal light. 'Cause, I mean, there's nothing else in there but ether.
I can't think of anything else. Possibly.
And that pink light, where's it coming from? Because the inside's not glowing.
Now, is that on both sides or just knobs?
I'm detuning it here to
And that went away. All the-
pinkish. You kind of see a little bit.
I think that's a reflection of the copper circles. It's definitely fluctuating to the music.
How close? So we're pretty close there. Let's see if we can maybe pull this apart. Maybe a half an inch on each side.
All right. Go ahead.
Okay, let's leave it there and let me retune. Let me stop the music while I retune it. Okay.
Here it comes.
Okay, so we're a little bit higher in frequency. Let me pull. Now that it's tuned there, let's keep going a little bit more. Okay.
You want to center it? I want to see that center ball light up again. That was doing some really cool stuff.
Yeah, I've never seen it have those little spinners in there.
It's like created a vortex there.
Let's see. Is it going again? Oh, look at that.
Still pretty. And we're getting juice to the backside too. Careful, we're just about to lose that off the. Yeah, you're good. That's good.
Tune a little bit. So with that right there, let me pull it apart.
Ah. Raise it straight up, see. Ah. That's center.
So we're pretty much up to about the highest frequency we can get. I mean, we can probably pull it a little bit more, but we're not really getting a different effect.
I'm wondering how hot the glass is getting now too.
Okay, so I'm going to turn this off and then okay, so this is the same geometry of tube as the last one. The center ball is bigger like the last one, and both of those are bigger than the first one. The outer tube on this is also has the hard vacuum on
That's
it,
also hard vacuum on the outer tube.
and then the inner.
The inner tube is 122 millimeters backfill of gas, 122 millimeters of mercury. So
that's considered really high pressure.
it's higher pressure than the other two bulbs.
Okay.
It's not considered high pressure. Atmospheric pressure is roughly 700. Well, it depends on the day, but at this altitude, 720 millimeters of mercury.
Okay.
So you're at 122 in the inner bulb on this, so it's still a considerable vacuum, but it's a higher pressure than what we had in the other two bulbs.
Okay. Oh, here we got the blue glow.
Okay. Now what's it gonna do?
So it's like it's going to transition to yellow and stay at yellow from that point. It's like
Something's going on there. It's
process.
concentrating into that ball again on top. Pretty purple color. Or blue. So what are you going to do?
Okay, so let's see. Let me.
Shrinking. Oh, went away.
We're gonna have this photo flash deal again, huh?
Oh, here it comes. There we go, bouncing around. Jump inside that inner bulb.
Should I detune it a little bit? Let's see.
There's a glow.
Okay, so not touching it.
Right.
And you remember it did that on the inside bulb before? And one of the small tubes?
That's odd. It's like it jumps out and, oh, there's different now.
Okay,
You've got it's like a fog on the bottom.
It's like a disc
Yeah.
almost.
Yeah.
Yeah. Comes through pretty good in the camera, but it's definitely a horizontal disc. Haven't seen that before.
And again, that outer bulb, we pumped all three of them at the same time. Oh. Pumped all three of them at the same time, the outer jacket.
Uh-huh.
So they're all at the same hard vacuum. And it's in the 10 to the -7 range. It's just the inner tube that's different, backfill.
Okay.
Oh, that's weird.
Purplish. You see this?
Yeah.
The color just changed.
Yeah, and it's like it goes out to the whole outer edge, surface, and then concentrates into that flat.
Blue, that's whitish.
Yep, now it's, see, it went back out to the outer surface.
It's definitely purplish.
Yep, yep. And now we're back to white.
Should we just let it do this for a little bit?
Yeah, let's just see how it acts. Maybe it'll decide to excite the center somehow. Boom.
And it's got that horizontal plane
Yeah,
in it. That's
and then it goes back to this. It's like a 3-step action that it goes through here.
Mhm.
Why are you doing that? Now, see, maybe that's the brush that Tesla was talking about.
oh,
And yeah, it just flashed back out to purple and
now one of the handheld tubes you made had that rotating deal. Were you there for the 20-to-1
no.
Colorado Spring?
Well, no, I was.
Eric brought one of the tubes you had up to it, and then it was rotating like this
Oh, was it?
near one of the coils. Yeah, the 20-to-1 scale model.
I didn't see that. No.
I think that was 2019, maybe. Okay, let's see.
One of my tubes.
I believe so. Yeah,
That would have been last year then.
and not one of these. One of the ones with the motorcycle. hand grips.
Okay. Yeah, no,
Might have been with the bluish gas in it.
That would have been the one with argon probably in the higher pressure. See, now that's a white ball there. Or brush as Tesla would call it. And look at look at that horizontal blue. Ah, you went away. Why? Because I was talking about you. I pointed my finger at you. Is that why you went away? Still pretty high
So it's lit.
potentials, yeah. There we go again. Blue circle.
I think your hand detunes it.
Maybe.
Yeah.
Yep, you're in there. Here it comes. we've got a that's a little bit lower power than what you were running before.
It's like it's incubating.
Yeah. Now you got, there you go. It cycles. It cycles between those three. There's you got your blue circle around the inside again.
I'm going to play music in this mode.
It's odd that it would point straight out this way and not circle all the way around inside, you know? There you go. That is so weird. It's cycling faster now.
Yeah, the music's getting it to. And each one has its own tuning. Each one is out of tune with the other, each of those phases. So it's hard to like tune it because as soon as it transitions, the tuning is a little bit different.
Yeah. Look at that. It's three definite modes. That is so weird.
So when the whole thing fills up, that's where it's tuned.
You're watching the meter then?
Mm-hmm.
It's still with that hard a vacuum, I'm still having a hard time getting it straight in my head. What is lighting up inside of there? What is the glow? I don't know if the camera.
Disc again. Okay, with it down here, let's see if maybe that triggers that center rod or something. So about peaked right there.
Nope, lost it. Now that's the one that has gas in the outer bulb. And that one doesn't. But if you hold the tail up in there, now you started to get some color in there.
Yeah, it's,
Yeah,
you know,
there it is.
yellowish.
It's starting to yellow glow in. And of course that one's going to have color all the time. Again, that's I believe I use the same gas, that nitrogen hydrogen mix in those.
So that's pretty much peaked.
So weird. Well, you can hear the transformers or the tubes humming. And tuning is completely different when you move it back into the center.
Yeah, it doesn't like it out here too much.
Uh-oh.
And this center tube hasn't lit up like that last one, huh?
Uh-oh.
See, there's a purple tinge.
Yeah, there
and
is.
It's coming from somewhere.
And there's a blue arc in the bottom.
Oh, the tube is almost kind of got a glow.
I see that.
You see that? See if the camera sees that. So the tube.
Yeah, you got kind of a purple glow on the glass on the inner bulb.
Raise this up, point it down.
I want to see that ball light up. Now, do we know what the peak voltage and frequency is? Or are we kind of guessing?
Oh, look, it's right on the border of those two spots, you know, where it likes to be at the bottom or the top.
Yeah.
So it's right on the verge. Because I detuned it a little bit, so it's not,
Quite so intense.
yeah, stretching it.
Oh! Yeah, we're back to our shifting transitions.
There we go. Now let me play some music into it.
That is odd. Yeah, when it bounces up on top, we're getting a blue reflection on the ends of the glass closest to the coils. Now the blue went away, but the purple on the inner bulb is still there. Now, if we go the other way with it to where everything drops out, and you've got that center ball lighting up purple.
See, it's almost like electrostatic, Earnshaw's theorem with magnets, where it's like you can't have like it stable in one point. A magnet will try to cling to one side or another.
Right,
And
you
it's
can't
almost
get a
like
balance
you,
point.
you get that point right there where it wants to either go to one part or the other.
Yeah, it's definitely undecisive on that. But again, this is kind of a fan. You know, it
I mean, from the side it looks like a flat disc.
yeah,
And then
exactly.
here it's almost like a candle flame shape.
Yeah.
And isn't that interesting? In some of Tesla's drawings, he almost draws the light like a candle
Yeah,
flame.
yeah. So I think we're close. I'm just not sure whether it's a matter of voltage or current or fill pressure or what, you know. We definitely have something going on here that I'm having a hard time understanding. And that's still, we still got a pretty good field on the back side of the coils. Let's see. That stupid thing is lime green. And that's just in the front. It's like from there back, there's nothing glowing at all. Yeah, see, there's your fill pressure, your fill gas. Yeah, grab the other one. Look at that. Now that shouldn't be doing that either.
Oh, a little RF.
Yeah. So we should be getting, there we go.
Both to light up. There's no gas on the outside.
No, there's no gas on the outside. So why is that? Why are we getting any color at all out there? I'll bring my tester coil down the next time I come down, and we'll plug that in. And I'll show you that there's no gas color light up in there. That's just odd. I don't get it. Yeah, kind of like a flat candle flame. It's squished up. Still running cool?
Yeah, not like the first bulb.
Yeah, you can put your fingers on it. Interesting.
Still warm. But
Oh, jeez, that's nothing.